Hello everyone and welcome to fourth day of GRUB Mini Summit 2020. This is the last day and today we will have two presentations. First would be very boring about licenses and discussion about the GPL v3 use in GRUB2. And second presentation would be like very exciting. We get good feedback on social media about it. It would be a discussion about RISC-V support in GRUB2. Okay, so let's start. So you know me, my name is Król, I'm founder of 3MDev. So I will not bore you with my intro slide. So the goal of this presentation is to discuss problems that current GRUB2 license may cause for embedded firmware market, and not only, because there are other cases considered in the presentation for the slides. So current GRUB2 license, like we think that current GRUB2 license limits its adoption in various applications, and I will try to prove that in this presentation. And of course, if we're limiting adoption of some software, then it may cause decrease in may cause a decrease in contribution and community growth. Then we think license should be clear and easy to read, and it doesn't matter if you are not English speaking. If you have basic English skills, the license should be should use language plain, simple enough to understand. And license should be programmers friendly, which I think GPL v3 is not exactly like that. Small disclaimer, of course, I'm not a lawyer and you should not listen my advice if you plan to apply that to your software development. I don't want to go with the discussion and start flame war related to politics, philosophy, or religion. So let's try to be pragmatic. But on the other side, I have my own opinions. I'm business owner, so I also have to take care of my business and of course salary of our employees and so on and so on. First of all, we believe that a copyright holder can apply any license to their code, of course, if it meets previously stated criteria. So, for example, if someone modifies GPL v3 code and this is just a small modification, of course they cannot change the license, and so on. Also, we believe that freedom and ownership, for example, freedom and ownership of software, or re-ownership in case of firmware, have to be associated with responsibility. So I have a couple of cases, especially from automotive industry, medical industry, military industry, where this is very important. And we represent a position that that we are a commercial consulting company and we work with embedded firmware sector. So we take care about spreading the open source firmware adoption in the embedded system market, but not also, we are also interested in laptop, workstation and servers as well. But we started from embedded systems. Yeah, and of course, like there are better talks about GPL v3 and how you can use that license. What are the best practices to using that license? So GRUB2 license was changed in June 2007 to GPL v3. I assume it was part of the massive change of all Free Software Foundation projects from GPL v2 to GPL v3. The question I have is, did anyone did some due diligence and considered the consequences of that change, and if the project, all the projects that were changed at that point complied with the GPL v3 license, and I will try to explore that later. So what are the difference, or maybe just like high level points about the difference between GPL v2 and GPL v3? First of all GPL licenses are focused on end user protection. It's not about vendor, it's not about developer, it's more about someone who is the end user of the code, which is GPL licensed. And GPL version 3 simplifies things like combination of various licenses. For example, it is easier to combine the code on Apache version 2 license in GPL v3 than GPL v2. Then GPL v2 seemed to be more about code and only code, but GPL v3 kind of extend its action and consequences to other things. For example, it defines something which is called user product. So it kind of implies what can happen with the product or how the product should be designed if it will build in or deliver with the GPL v3 licensed code or binary, even object code. In case of statistics, just to compare the complexity, of course, this is legal jargon, written documents, but we can compare the size and the complexity, and we can see that GPL v2 had around 340 lines with 3,000 words. GPL v3 has 674 lines with over 5,000 words. And for example, MIT is 26 lines with like 170 words. And of course, this is just like based on examples that you can find in internet. Of course, like GPL v3 life is shorter. It's since 2007. Of course, there were drafts which were reviewed before, but right now, so we have like around 13 years. And of course, GPL v2 is on the market way longer. And because of that, probably it was exercised in more cases. There is lack of compatibility if we have projects which use GPL v2 only libraries. So then we cannot apply GPL v3. And one of the like very important points of GPL v3 is to protect users against kind of malicious or unethical vendors which limit user freedom in scope of the software modification. So if some vendor will deliver device user product with GPL v3, there is some additional action the vendor have to take and the freedoms that have to provide to the users. In case of commercial use, so GPL v3 of course state that you may charge any price or no price for each copy of the work that you do on GPL v3, and of course you can offer support for that or some warranties. So it's okay to charge for GPL v2 open source code. It can be used with the commercial products, but put some requirements. For example, you have to deliver source code, and there's GPL v3 specifically defines how the source code should be delivered for, and the same as GPL v2, it means that it have to be delivered for 3 years after product release. And you need to deliver also instruction how to build, and the tools that you build with, either you have to open source also, either those have to be already available on the market. As well, you have to provide install artifacts and how those artifacts should be deployed to your system. In section 6, we have definition. This is like probably more. Section 5 and section 6 are most controversial, and there were the most discussion about that. So this section 6 defines user product, which is the definition of user product is not exactly clear, but vendor of user product have this kind of freedom to refuse to provide support, warranty, or updates if the firmware will be modified. And of course, if this is GPLv3 code in user product, user have ability and have a right to update that code and modify that code. And of course, we can see there is one small caveat here. This does not apply to boot ROMs because in section 6 we can read, if even vendor is not able to modify the code, so nobody is able to modify the code, then a vendor does not have to provide this right to the end user. So we can say that, but of course we need to provide source code. So if someone puts GPLv3 in boot ROM, which cannot be updated, that's fine, but source code have to be provided. The big thing about GPLv3 is something called TiVoization. To be honest, like there is no talk about GPLv3 without talking about anti-TiVoization or TiVoization. So the term was created by Richard Stallman when he referenced software which were delivered by TiVo with their digital video recorders. They used kernel plus some patches for kernel and additional Linux tools. But they signed everything and they remove ability to update that software on the device. So you cannot run modified software on the TiVo device. And there is a nice talk or comment of Linus Torvalds when he was asked about GPLv3, and he said that he has no problem with TiVo case because all he cared about is that someone will contribute the patches back. And TiVo did the contribution to Linux kernel. But of course, if Linux kernel would be GPLv3, in this situation there would be violation of GPLv3. And there was a lot of discussion about TiVoization and like how this can impact the ecosystem. And initial draft was very kind of against TiVoization and was strong about TiVoization, strong against TiVoization. But then during the discussion and further draft releases, they kind of allowed to exclude like a medical device or voting machines. So for example, in case of voting machines, there is a situation that, let's say, government obtain those machines, provision some keys, and then distribute to some places where the voting happen. So that means there is no really, this is not end user product, and there is no delivery to someone else. It's still in the same organization, we can say. That's why they say this not apply. And medical device is other thing because it can somehow violate law if we will not comply with, for example, firmware for medical device can be updated only by manufacturer, for example. And there was interesting response from James Bottomley and various other Linux maintainers. They raised a couple points. You can find their answer in the internet, but definitely they were concerned about GPLv3 statements, and they said that in the summary that they said that it limits adoption of free software in comparison to GPLv2. From perspective of embedded firmware market or embedded firmware vendors. Definitely the situation is like most of the hardware devices are useless without some software. So if we will imagine that this software would be licensed using GPLv3, definitely the vendor would limit the buyer, or like, let's say it is like some ODM who release the device which has the only available stack using GPLv3 license. That means that the people who would like to use that hardware and deliver further products on that will have some limits in providing applications and creating applications using that hardware. And because of that, we think that silicon vendors or ODMs would never benefit from GPLv3, or they will think that GPLv3 may limit their benefits, and that's why they would avoid that. And it is hard to me, for example, to imagine that Intel or AMD could be convinced to use GPLv3 for ME or PSP. And of course, in light of Free Software Foundation, look at this point, of course, GPLv3 should be applied to those components, and that would be the best situation that we may have. So GPLv3 was very controversial from the beginning. It's hard to explain all nuances, and when I tried even read some lawyers' opinions, and in some cases I tried to discuss that with vendors' lawyers or legal advisors, they were very confused, and they just don't want to have this work of trying to explain to their bosses how to avoid all possible problems that this license may cause. And because of that, because of this additional work, because of the complexity of the license, because of the lack of clarity, typically the conclusion is that let's avoid GPLv3 and just forget about it, using it in an embedded system. Let's stay away from that. Even more, these controversies related to GPLv3 cause a situation where some vendors even scare about other GPL licenses because they do not understand that. So sometimes they may think that GPLv2 code can be at any point updated to GPLv3 and any further license. And if this is the evolution of the license, then let's avoid any GPL code. And of course, this does not help embedded firmware market and open source on embedded firmware market. In case of regulatory issues, some products from automotive, military, medical markets by GPLv3 are not user products. So GPLv3 define user products which have some, and vendors of user products have some obligation when using GPLv3 code delivered on the machine. So they have to give ability to update that. If the update is signed, they need to provide authorization keys to give the ability to update that code. But automotive, military, medical stuff may be considered it's not user product, it's not end user, but still it is worth to discuss implication of GPLv3 if some of those will be similar to user product. So for example, of course, car is a questionable, because car, we can say that car is a user product, but it can be easily illegal to write a car with modified software. So applying GPLv3 to cars could be very problematic. And of course, already we know that there are cars which, for example, have some form of bash, which is GPLv3. And that was raised a lot of discussion in automotive industry. So it means, so for example, if you have infotainment system in your car, and somewhere inside it has Linux with some form of bash, that means this is end product, and you should get ability to update that bash. So it means it may cause some problems to certifier or someone who makes sure that there is safety and security on the streets. In case of military, U-boot is very popular there. I didn't saw GRUB usage in this ecosystem, but still, I believe if they will consider some projects, they will avoid GPLv3 license, definitely. In case of medical, we had the situation that we leveraged Beats, which is modified version of GRUB with Python module. This was in medical robot, but it was just for testing purposes. But we can easily imagine how this module could be used as a debug mode or as some extending mode for administrative purposes or diagnostic purposes. Of course, because of various concerns related to the GPLv3, we would never be able to do that. But in this case, it was never delivered. It was just for self-testing. In case of security, combining SCRTM, so having some static code root of trust for measurement like Intel BootGuard, and DRTM, so trench boot, would be something that provide best security on x86 hardware. And because GRUB2 is reference bootloader for trench boot, we would have problems signing the GRUB and deliver that in user products as a signed component. We will have to provide the signing keys, so somehow someone can update that, or we will have to give ability to reprovision platforms to the user, so the user can deliver their own keys and sign the GRUB. Of course, that means they have to build the GRUB. They need some procedures for that. They need well-documented solution. So it means you cannot kind of provide closed product with GRUB2, or product which without additional documentation can be shipped to market. Okay. Yeah, so let's discuss that further in secure boot discussion. Yeah, so there are also some products which by law cannot be modified. So for example, there are fiscal devices, and we saw some fiscal devices which initially used GRUB because this was Linux. We saw many devices that use default Linux like CentOS, Debian, and then based on that someone building some applications. Of course, finally it means they cannot use GRUB as a bootloader in those devices, and of course this limits application of GRUB in this kind of devices. And fiscal devices, for example, certification of fiscal devices means nobody can update this firmware. This firmware have to be as it is right now, as it is at point of certification. In case of secure boot, verified boot, measured boot, we have something which is called crypto lockdown, because, for example, Microsoft Surface laptops are completely locked and can be booted only with given keys and only with given operating system. So of course there is no GPL-v3 code there, but we can imagine that if we will have similar device like Microsoft Surface, but Linux, like completely Linux based, usage of GPL-v3 code in the boot process, like GRUB2, would be problematic, and we will have to provide a mechanism of kind of update this component. So what kind of option GPL-v3 gives in this slide? First of all, we can have switch to developer mode. It's like in Chromebooks where we have screw and we just open the box, we unscrew, and then we can update firmware. This similar thing is suggested by GPL-v3 activists or people that admire this license. So you have some magic way of switching system into the developer mode, and then you comply to GPL-v3. Despite switching to developer mode, you're losing various things, like you may lose warranty, you may lose some services which are provided to you thanks to keeping the developer mode, keeping the production mode, and so on and so on. So it means that you definitely get rid of some additional stuff, but you need to provide that to comply with GPL-v3. Other thing is to provide crypto ownership, and this can be done through provisioning of user-owned keys. And this is like, for example, if you know how to provision secure boot keys, this is exactly the thing that is needed to comply with GPL-v3. So let's say we have some device which is like Microsoft Surface delivered to you, but with GPL-v3 code. So you can kind of switch and say like, okay, right now, please just boot the code which is signed by me, which is good. And of course, we love this kind of solutions. As open source firmware vendors, we are in favor of that path. Yeah, so as I said, this about updates, and of course, like, so there is important kind of, I don't know, policy or tribal knowledge, or I don't know how to say that. There was some point where LibreBoot was created, and they claimed that core boot do not work for freedom because core boot allows binary blobs like FSP, IGSA, and other binary blobs. So they created LibreBoot, which is a set of scripts to deblob the core boot. But then why core boot choose the path of like using those blobs? I don't remember who said that, but probably this was Stefan Reinauer, and I most surely misquote him, but he said something like, I would rather have 1000 boards with core boot with blobs than 10 boards, and those boards would be probably newer than 10 old boards without the blobs but with LibreBoot. And of course, from that time, from that decision, adoption of core boot moved forward very fast, and we think that being radical about the freedom and about enforcing GPL v3 related license and conditions is kind of limiting to spreading the word of open source firmware, because this environment is a little bit different than higher layers like in operating system. And because of that, we think that GPL v3 is not good for firmware and something which is built in the system, since we already have huge problems convince anyone to even GPL v2 code. So first let's start to walk, then we will run, and not we will not win just by one move. Yeah, so this is our position. And by kind of thinking about violation and enforcement, yeah, we are sure that most of the Linux laptops, or probably all of the Linux laptops which are shipped with some distros, what general purpose distro, use GRUB. So the question is if those all those laptops really comply with, and the question is about secure boot on them, and how those laptops comply with GPL v3. Because all the requirements are hard to fill and maintain for long run, and the question is like if those vendors comply to that. So of course it means like if vendor ships with GRUB2, they probably should say, okay, how this GRUB can be updated and so on and so on. Or maybe this is resolved by distro, and they say this distro just resolved that problem, and because of that, this is not the problem. And maybe also there is different thing, because nobody tried to enforce the requirements of GPL v3 for Linux laptops or different Linux devices. And other thing is that Michał Żygowski pointed, are we really sure that all the projects comply with the GPL v3? Because there is some statement in GPL v3 that's saying if we have terminal application terminal interaction, then we have to put some copyrights notice, which is not visible for probably in most of the terminal application licensed using GPL v3. Okay, so just to start to sum up, what are the pros? Definitely user gain a lot of rights, and it's good for end users to have as much GPL v3 code as possible. But first of all, someone have to deliver something, deliver some device or some solution with this code. And I believe, like, in interest of most of vendors, it would not be something they want. We can use GPL v3 in read-only memory. Of course, that has a lot of drawbacks, and this is the solution, like I said, about boot ROMs. But what are the drawbacks? So we should not be surprised about rising of alternative options of booting and avoiding GRUB2 let's say FE stub, which kind of gives ability to boot Linux directly from UEFI shell. And the question is how many developers, like low-level developers, because higher-level developers, like application developers, may like GPL v3. So the question is how many low-level developers really want to provide contribution under GPL v3. And if we look at the statistics, what's going on with GPL v3, we can see it is in decline. And definitely MIT gaining way more projects. So like as final discussion, I would like to raise other problems which are a little bit related, because I believe GPL v3 to some extent enforce user product ownership. And the question is, do we understand who owns our computer systems? And this problem was discussed by many researchers. I believe Joanna Rutkowska many times mentioned problems related to that. Open source firmware community knows very well about that. So it seemed to be simple from hardware perspective that that we gain like ownership by buying something. Yeah, we're going to the shop, we're buying a hammer, and we are owners of that hammer. And we typically, like when we are owners of something, we typically get the right to modify, use, and even destroy given hardware. But the question is if the device we're buying or user product we're buying has some additional with it, like some firmware. And to be honest, like all our computers right now have tons of firmware. Every component has some firmware. Which typically is in form of binary blobs, because we really don't know what's inside. It's just a piece of bytes, sometimes even encrypted. So without those blobs, if we say like, we don't like these blobs, let's remove them, the hardware is useless. Like we cannot use hardware. And typically in this case, we're just getting a lot of papers that we even don't read. And it is important to understand that typically we are just licensor of these binary blobs. We can use those binary blobs with certain conditions. We, for example, cannot reverse engineer those, like in some legal areas. We cannot kind of modify them, and so on and so on. There are some limitations to the usage of those binary blobs. And some may argue that if you don't have full control over your hardware, you cannot replace all the software components. And I believe this is the message of GPL v3. You don't really own your computer. You don't really own your system. And to be honest, we agree with that. But the problem is, what's the path to break through that? And if the GPL v3 is the real path to break through this problem. Yeah, so of course, like this has also some security implications. You cannot audit what's running on your system. And on the other side, those blobs which are on your system can be damaging to you, and the owners or someone who created the license for you for these blobs have no responsibility of if they do any damage to you. So that's kind of additional problem. But in other environments, like in automotive, military, medical, there are special procedures and legal enforcement, so the vendors take responsibility for negative action or something. So like the Volkswagen case, where they did the modification and they paid huge fees because of the weird manipulation in the firmware. So let's consider change of license. Like I believe, like previous slides say, we don't own our computer systems and software on it. And if the GPL v3 is the correct path, I think not. We should probably use something different, but what? So let's consider change of the license. First of all, the huge problem is that all the contributors have to agree. I wonder if all the contributors to the Free Software Foundation code, which were licensed on GPL v2, agreed to move the code to GPL v3.
Actually, this is from GPL v2 plus to GPL v3 plus. You don't have to ask anyone because it was always GPL v2 or later.
Okay.
And then you can just take the same code, replace it with GPL v3 or later, and distribute, and the deed is done.
Okay, understood. So the question is about the projects which had the term GPL v2 only, not GPL v2 plus.
We didn't, as far as I understand, we didn't have such code in the code base.
Okay. So
and for reversing, actually there are two ways. Either all contributors agree, or FSF allows it to happen, because copyright is assigned to FSF. Like every contributor assigns this to FSF with a grant back clause, and the grant back clause allows it to redistribute under another copyright.
Okay, that's very interesting information. That when you're trying to contribute, so I believe this is concerning for me. Why? First of all, because I don't know what FSF long-term agenda will be. Of course, I understand they saying they protect end-user freedom. I understand that, but the question is what kind of tools and what methods they will use to protect that freedom, and I may not agree to all the methods. So that's first point.
Well, you don't have to sign this contributors agreement. It's just the default way.
Okay. So you can contribute and not sign it.
Yes.
And then when this happened, so how the move of the project to the next version of license will happen?
The move to the next version of license is simple, because the entire code base is licensed as GPL v3 or later.
Okay. I understand. So I understand. So there are two things. Those are two threads of discussion. So first thread of discussion, if there would be GPL v2 only, and no matter that there is GPL v2 only, because you transfer the copyright to FSF and they can decide for you. So it doesn't matter. And on the other side, all the other projects are GPL v2 plus and GPL v3, which means that all the new license can be applied without problems.
Yeah. And the reason of FSF assignment is actually a different one. Is that if you imagine a case where, let's say, GRUB would get used in some way which completely violates user rights, let's say huge modifications, and then it would be hidden, and the user not even informed, and then when asked for the source, they would not even reply that we are not supplying you source code. Then FSF would be able to sue you, because otherwise only the individual authors would be able to sue, which is very complicated.
Okay. Yeah. So and to be honest, like in case of Linux, that was kind of the problem, because like it was impossible. Like there was discussion about GPL v3 for Linux, but it doesn't make sense because no lawyer will allow that, because all contributors will have to agree, and there are like thousands or like tens of thousands of contributors of Linux kernel. So so this is a question about feasibility, but I assume that if Free Software Foundation wants to change the license, they can. But the problem is they will probably not change to something that I will suggest further. But anyway, I believe for some projects, GPL v3 and GPL v2 are great license, but not for all of them. In case of market share of the code that was created in 2019, 67% are permissive license. So, like those are not GPL license. Yeah. So the code, of course, that we know about, the open source code. Above those 67%, the most popular is MIT license, which I already show how long it is and like how complex it is. It's 27% of the market. And of course, like Mark, I don't consider MIT as a good replacement for GPL or license, because this would be like huge revolution. But from perspective of the embedded firmware market, I believe MIT would be way better. But of course, like for embedded firmware market, even GPL v2 is better than GPL v3. Yeah. So and the problem with GPL v3 is it's complex. It's not easy license. Of course, there are more complex licenses on the market. But on the other side, if you're trying to convince some vendor to use GPL v3 code, and they have legal department which kind of trying to analyze that, it's like almost impossible to convince them. And to be honest, even for me and for like my fellow friends from 3MDEP, it's hard to understand some definitions and to classify some products, if this is user product or not user product, or what the corresponding source means, if, for example, system libraries are also corresponding code or not. You know, like this is not plain, in my opinion. And now we can switch to discussion. I believe, Vladimir, you have your opinion, so would be glad to listen to you and know what do you think about that?
I think that it's I'm personally think it's I'm kind of open to the possibility. I've already relicensed a few pieces of the code that I contributed when I was asked to. But if you want to boot on a BIOS system, so EFI, you need some basic code from other people. So I am not a person who can give you this. So basically you need agreement either from FSF, and which will probably would mean Stallman.
Mm-hmm.
You need the agreement from several basic contributors, which will probably involve the people who are not with the project anymore, probably Bin 123 and Oshinori Kayokui.
Mm-hmm.
And that might be a problem because it's like Oshinori Kayokui. Last time he appeared, perhaps it was 2014, perhaps. No, it was not 2000. It was 2012, I think. And before this, he had a hiatus of 2 years, and he hasn't appeared since.
Yeah, but I don't think this idea is even like I will not pursue it myself. I believe this is like I'm talking with maintainers of GRUB, so I'm just letting you know that what kind of things embedded firmware people make. If you said about UEFI and this kind of code, please note there is work on Power. On Power, you can build the firmware without problems, and you can own full firmware stack. In case of Intel, for some platforms, it is also possible. So for AMD also. So of course there is ME, there is PSP, there are other problems. But to be honest, the question is rather for embedded market, because like from my perspective, it's hard to work with embedded market people and convince them about using GPL v3. And more to that, it's general for GPL v3, but it's also important for GRUB2. So first of all, GRUB2 adoption. So for example, GRUB2 gets trench boot reference implementation, gets RISC-V implementation, and has like a lot of cool features, a lot of nice stuff. But then the question is if really if the ecosystem and the license and the way code and contribution is handled is welcoming. So from the license perspective, I think that for some reason it may be not welcoming. For example, if embedded system consulting companies in the world would like to contribute some additional features to GRUB, even the features that their customer wants, they have this problem of convincing their customers' legal departments that this is safe and okay and so on and so on. And getting through that is a problem. So yeah, and in that way, it limits the ability to contribute to GRUB and to develop something for GRUB.
If you look at this perspective, we have actually some files which are under the licenses a bit different. Like for example, I think we have few files which are under GPL-v2 or later. We have few files which are under GPL-v3 or later, dual licensed with MIT. For example, files which relates to multi-boot specification, they are dual licensed.
Okay.
And I am completely open with having dual license files. The only thing that I want to basically it to be clearly marked, and in the modules we write in the metadata field which license it uses.
Okay.
So and like for example, we have Lua module which retains the same license as Lua, because it would make no sense for us to somehow change the license for it. And I believe that if we import some project, we should keep its license. And I think if it's properly marked, and it should be, then GRUB models are LGPL version 2 or later models. And so on. You can basically have models under any compatible license.
Okay, understood.
In general, I think that it is very nice presentation, and thank you for doing this, Peter.
It was not easy for me, as you saw.
I can imagine, but it is. I think that it gives us it shows us your point of view, and it helps us to understand what are the needs with regards to the legal stuff for GRUB project. I think that it requires more discussion how to solve this problem, and we are not able to do that during this presentation. We have to this is too short time. But anyway, I think that we should start looking at it and to start discussing this among maintainers, and start looking at maybe changing the license, or maybe it is possible to clarify some terms in GPL-v3 to make it possible to make it easier to use the GRUB with GPL-v3 by embedded companies.
So one thing which is important is that I saw the problem with when we started to build in GRUB into SpyFlash, because then you it's not so easy to update. And I started to think about that, and to be honest, like if you have to provide the methods for updating, and then even if you will enable like verified boot, then you complicate things and kind of adds some work for you if you want to deliver this kind of product. And of course, nobody wants to extend the scope if they can limit the scope of work.
Sure.
Actually, I think it's when we will speak to other people, because like I think it would make sense perhaps to speak to Robert or so on. And if you start talking about something like we would like to change the license of this code, then we might get a question like, hey, do you want to enable TiVoization by someone? So it would be helpful if you could perhaps, in addition to sharing your presentation, prepare perhaps a short doc with few use cases that relicense would enable.
Mm-hmm.
I would like to underline that we have also other options, not only GPLv2. There are tons of different kind of open source licenses. I think free software licenses which are promoted by FSF. So I think that we can try to use the license which is the best for the project, or maybe it makes sense to dual license the GRUB.
So just to make sure, Daniel, like from my perspective, GPL v2 is okay because it does not have this user product stuff. And to be honest, there is big difference between those two. Like there is big difference between GPL v2 and GPL v3. So
I'm not sure that it is easy to go back to the GPL v2.
Okay.
This process may be complicated. Anyway, as you said, we are not lawyers. I think that it requires.
Yeah,
we should start doing this as a maintainers, but I think that it requires a lot of discussions with lawyers, which will help us to understand various things in the various licenses, and maybe they will be able to help us to choose the best license which fulfill needs most of the companies or people who are using the GRUB, I think.
Yeah. So on the other side, like I believe one of the main points that I had, and I kind of have this conclusion about after presentation, after reading all the materials to prepare that presentation, is that GPLv3 seem to limit the adoption of the open source code in the embedded firmware market, because we already have huge problems there in light of completely closed ecosystem. And as Stefan Reinauer said, or I paraphrase him or someone else, but I'm not sure, I don't remember exactly, I couldn't find the quote. It's better to move slower but forward than saying that I will jump, I will do huge jump, huge revolution, but then nobody will move, nobody will help you, like you are your own. So you kind of yourself want to win the game. And I believe that's the problem, that to make change in the ecosystem, we should do evolution, and GPLv3 seem to be, at least in the area of user products and kind of built-in firmware and signed components, like in case of TiVo, it's kind of trying to do the revolution, which not work. And I see that it doesn't work with my customers with the environment that I'm operating in. And that's my biggest concern.
It would be pretty difficult probably to persuade RMS to go back on TiVoization statement.
Mm-hmm.
And I think that Richard Stallman brings up very important topics. But I agree with you, Peter, too, because I think that if you try to strongly, let's say, to stay on your place and to move on, then as you said, it is difficult to convince people to use the software, for example, with GPLv3, which looks quite radical, and from a legal point of view, it creates a lot of problems. So I think that we should try to balance both approaches. I think that people like Richard Stallman are important because they are showing various problems which appears in different places, and I think that it is important. But on the other hand, we should try to find the best solution, which allows people to use the free software, the open source software, in the easiest way and in the legal way, let's say. This is a very difficult task, but we should try. I think that we should try to do that, and maybe maybe we will not solve all the problems at the beginning, but we should try to solve these problems for at least for GRUB, I think.
Yeah. So recently there is a project called Spy for kind of doing nice things around SPI reading, SPI flash reading. The project was created by Trammell Hudson for research purposes. So it's this, I believe it's a piece of FPGA stuff which gives you ability to do talk-to attacks and to sniff what's going on SPI bus and even replace some messages and like trick the reader. So which means like if you have a BIOS in SPI, then when CPU reads that stuff from the SPI, you can kind of play with that. And this is the tool for that. And there was no license for that, and someone asked Trammell on GitHub and proposed GPL-v3 and AGPL. And the discussion was, I saw discussion internally on open source firmware Slack, and there was like a lot of pushback from open source firmware that like, no, not do that on GPL-v3, please do not use that license, and so on and so on. And eventually Trammell decided to go with GPL-v2, which is great, and I believe, and he also justified that he are not concerned about, let's say, someone doing product with that or some other stuff related to. So we can see that maybe I don't know I don't know what's Trammell motivation, but to me it looks like what Linus Torvalds said, that I care about contribution back. So someone will give back the code if they will modify that, and that's the most thing about software and about associating license with that software, and GPL-v3 trying to go one step further, which kind of enforcing the situation of the hardware and the product that is shipped with that code. So that's kind of the difference, and that's kind of small story related to recent license applying to some new projects and discussion about that. Okay, we have 3 minutes. Any further comments? Okay, so let's switch to the yeah. So I believe like we can take a small break, like 3 minutes break, and let's get back with RISC-V support in GRUB. Hello everyone, and welcome to the RISC-V support in GRUB talk. This is last talk of this year GRUB mini summit, and I will present it with my fellow colleague Michał Żygowski, from firmware engineer from TrendLab. Okay, I will not bore you with that
Hello.
slide. Hi Michał. And huge kudos to Norbert Kamiński, who's helping us in this presentation. He's 3M Junior Embedded System Engineer, and he kind of glued everything here, debugged and help us get the correct demo. And we are just, with Michał, just the presenters. So kudos to Norbert for all the work. What's the goal? So the goal is practically demonstrate GRUB2 on RISC-V. Unfortunately, emulated environment, we don't have real hardware, but who knows, maybe after this presentation, someone will ask us to build whole firmware stack for RISC-V. Feel free to do that. So we would like to present the boot firmware and the bootloader ecosystem, but why you should care? So RISC-V is one of the most important trends in semiconductor industry recently because of open source license, lack of license fees, and royalty for creating RISC processor from templates. And there are some already existing templates that you can use, but there are also multiple applications that you can apply RISC-V not only general purpose computing devices, but also dedicated processors, and I will talk about that on next slides. And who and why should care? Definitely one person, definitely people from open source firmware environment and bootloaders developers, because healthy open source firmware and bootloaders ecosystem definitely helps RISC-V to create correct CPU initialization and provisioning of various dedicated features which RISC-V wants to provide. Silicon vendors, which will depend on the firmware and bootloaders reference implementation, because of course silicon vendors should contribute to the ecosystem, so their hardware can be sold in bigger quantity, and of course to expose all the nice features and everything what processor provides to higher layers. Definitely IoT embedded system makers, since RISC-V seem to be very, very strong on industrial and IoT or industrial IoT and like consumer IoT markets. So firmware and bootloaders for that market can help deliver advanced platform security features, trusted environment for execution of the applications in this ecosystem, which is needed because we saw many problems in IoT ecosystem. In case of security providers, the RISC-V and then of course stack on top of that helps in efficient leverage of various features and management capabilities. Also, like AI and machine learning and analytics counts on RISC-V. And of course, if we have various workloads that this application use correct initialization of the processor and all around all the peripherals is important to make those applications work correctly. Other use cases that we saw, definitely there is a big move in the hardware acceleration market. So if we have main processor, let's say it is x86 or power, and then we want to have some market-specific computation, which is as fast as possible, it's definitely easy and nice to do with RISC-V. But of course, that means this RISC-V needs some firmware and bootloader to boot the application that will provide this market-specific computation. And of course, all the fans of Libre freedom computing, and we have like huge hopes related to RISC-V. And if this would be possible to create computing devices which are performance comparable to today's laptops, today's x86 platforms, open source firmware stack and bootloaders would be very important, and everyone would like to have that. As introduction to RISC-V, so RISC-V is a free and open instruction set. It enables new era of processor innovation because it's open standard. It promotes collaboration, and it's very extensible. It has a good kind of community. When we tweeted, when we posted this information that we will do this talk, we had a lot of action on social media, a lot of likes, a lot of retweets. So that's very important. It was created a long time ago, but didn't get a lot of traction, or didn't get a lot of traction in the realm that we know today. Definitely market was dominated by x86, but now when we have problems with Moore's law, definitely architectures like RISC-V can shine. Of course, we can talk, okay, how this compares with power. So we can say the difference is that to build power processor, you need a license. Of course, IBM provides it for you without any royalty, and they encourage you to create power processors. I don't know how many companies did that, but still, this is IBM ownership. And in case of RISC-V, there is only foundation which takes care about compatibility and about making sure the ecosystems, tools, and software stack will be compatible across various RISC-V implementations. So it's a little bit more open, but still comparable to Power. Yeah. In case of system architecture and software stack, which we will use in this presentation. So we used QEMU for emulation. We used EDK2 forks dedicated to RISC-V, especially those for C5, High5 Unleashed board. We used GRUB with support for RISC-V, which was released in the version 2.04. And there are also some patches related to Linux support to boot it over the UEFI. And we use Open Embedded Yocto for RISC-V, which is Meta RISC-V on our GitHub. Little bit history. We enjoyed Alexander intro to the patch set. So Alexander Graf contributed initial support for RISC-V, and it was in 2018. And he said, as a part of the plan for total world domination, we would like to make sure that booting on RISC-V is in a sane state before anyone goes and does quick hacks just because. So great intro, and I believe this was important step. Of course, at this point, U-boot already had something, so it was natural that GRUB also have to gain this support. Patches were merged in 2019, but then, of course, the problem is we're looking at the patches, we're looking at the patch series, we see that someone tested that on hardware and even on some QEMU, but there are no precise instructions how this person did that. Of course, we could reach that person and kind of ask the questions, but nobody is so active on the community. And to be honest, like it's hard to imagine that someone will quickly reply with the instruction. So we had to, and to be honest, there should be no question about that. We just should know how to test that. So how this look like from the visual perspective? So we have QEMU, which emulates BIOS. Inside BIOS, we put it EDK2. There was plan to put core boot, but we saw that there is like a lot of limitation, and we were not sure if we will have enough time to run GRUB on top of core boot that will work for this configuration. But definitely this could be another talk, or maybe on FOSDEM, or maybe at some other conference. We also provided HDD emulation through QEMU, and inside QEMU machine we run GRUB2 and our Open Embedded Yocto Linux. Okay, so yeah, so this is the link for UEFI implementation for various platforms. I believe sooner or later it will land upstream in the official EDK. What it supports various targets. First of all, the Unleash machine that we said. There is also Freedom U500 FPGA support, Andes AX25 FPGA support, and there are like Vitro.io, Virt.io machines which are also supported. In case of GRUB support, there is a little bit of additional effort needed. Some patches already landed. There is some criticism to those patches. Those have to be improved, fixed to boot Linux, but it was not so obvious, and this will be presented by Michał.
So thank you, Piotr. So let's start with how we even built the indicator for RISC-V. So as a starter, it was not so easy to find the proper branches in the commits that we should use to build a working indicator image, because the development is still a work in progress, as you may visit on the indicator docs site for RISC-V. And certain functionalities are either in the upstream or not yet upstream. So as you can see, we need at least 2 repositories for EDK2 and 1 repository for the toolchain. For the EDK2 repositories, we have used branches that were supposed to have support to booting Linux kernel. However, as occurred later, we had to go back with a few comments on the EDK2 repository because the disk emulation didn't work quite well with EDK2 in QEMU. And yes, and when we clone all the repositories, we need to install all toolchain dependencies that we will need to build the RISC-V cross-compilation toolchain. And yes, as you can see, there are many dependencies. So this process should be rather containerized, and we should have the correct toolchain already present in the container. Please, next. Okay. Okay, so to build the toolchain, it requires just two simple commands. We execute the configure, and we pass the prefix to the target directory where the toolchain should be compiled and installed, and we just type make. Well, it took about 1 hour on a, well, let's say average i5 processor, 8th generation Intel processor. So it's rather long. Another reason for oh, please, one back. I didn't stop. Thank you. So it is not so quick. So another reason that tells us to make it containerized. And at the end, of course, we add the cross compiler to the path environment variable to have it visible for any other applications and make itself. Now, next, please. So now we can approach the initial configuration of the EDK2 environment. So workspace and packages path are two base environment variables for EDK2 build. And it should point to the main repository. The workspace should point to the main repository of EDK2, and eventual other directories which contain the build packages should be in the packages path. So, of course, the EDK2 repository is one source of these packages, and it contains mainly reusable generic packages. And then we have also the EDK2 platforms, which is a repository dedicated to specific silicon initialization and platform related code. So if you have the environment variables ready, we execute the EDK setup script, which is a normal step for each build, not only for RISC-V. And of course, we need the EDK2 base tools compiled for the build. And then at the end, of course, we must indicate that we want to cross-compile for the RISC-V architecture, and we should define the prefix with the cross-GCC binaries. And now, if we are ready to build the RISC-V, we just execute the build instruction. We pass the architecture and the toolchain that we want, the GCC5, and we point to the correct description file for given platform we want. So in our case, it is, of course, the Freedom U540 for High 5 Unleashed board, and that's it. Please, next. So now let's have a talk about the group EFI support for RISC-V. So it wasn't that straightforward and easy to just make Yocto to build this image. So we used it to prepare the proper initial RAM disk we have used to in our software stack, and in order to launch the kernel and GRUB, we need, of course, the FAT32 partition on our disk for UEFI. And we had to prepare an ISO image that was loaded as an embedded RAM disk instead of HDD emulation because we couldn't resolve the issues related to virtualized block devices. So for those who don't know, the Yocto project is an open source collaboration project that helps developers create some custom Linux-based systems or even whole distributions, regardless of hardware architecture. You may find the source code related to our work at our GitHub meta RISC-V. Next. So to start the build process of Yocto, you have to get to know what CAS is and how it works. Typically, open embedded projects don't download the source code on its own. Everything has to be prepared manually. So CAS is a very simple framework that integrates with various bit-based projects and helps to manage the source codes and repositories used in the build process. So it basically takes to prepare a simple YAML file that contains the project configuration with all the repositories and versions we need. And then we just download the CAS repository from Siemens GitHub, execute the CAS Docker with the YAML file we need to start building our image. So when the build is finished, we go to the deploy directory where we can find the images for the target architecture and configuration. Next, please. So as I mentioned earlier, we had to do some workarounds with the image containing the Linux and GRUB because we couldn't get the HD emulation working. So in typical QEMU testing, we should just mount a raw disk image to be emulated, and it just didn't work with EDK2. So we just prepared some simple ISO file. We put our group EFI and fit image containing the kernel with intramfs and just included it in the EDK build, which will be presented on the next slide. Next, oh yeah. So we copy to the Linux ISO to the EDK2 repository and our device tree blob, and then we have to rebuild the EDK. And as you can see, this ISO image is put into ESP RAM disk. This RAM disk is later used in the official to mount an embedded RAM disk and then launch the GRUB from the mounted image. Next, please. Yeah, but before we start launching our image at EDK2 BIOS image, we need to have some newer QEMU. Typically, the QEMU delivered with the distribution package manager is not sufficient and is quite old. So you may visit the RISC-V getting started guides and see how to compile the QEMU. So now we go to the target EDK2 BIOS directory, which contains our firmware volumes for the RISC-V BIOS. This is typically named by the platform name, the debug or release, toolchain name, / firmware volume. There we can find the FD file, which will be used to launch our emulated platform. So as you can see, the QEMU command, we emulate the CPU present on the C5 U540 SoC. We also emulate the machine C5 and used our FD file produced by EDK2. We give some 2 gigs of memory. We indicate that there's no graphics, and give some 5 CPUs to the QEMU. As you can see, there is no HDD emulation, as was presented in the diagram. However, this diagram shows an ideal case where we don't have to put everything into the BIOS. On the RISC-V repositories, the embedded RAM disk support has been reverted, and is probably planned to be implemented in real hardware. For QEMU, there's also some work to integrate the OVMF packages, which are used for virtualized environment, and probably we can expect the correct support soon. Please, next. So now Piotr will show you the cinemas which present the EDK2 boot flow and how the GRUB is later, how the GRUB is executed by the EDK2. So as you can see, we go through the pre-FE initialization phase right now, and now wait for the driver execution environment to be loaded. Yeah. And we shall soon be in the FE shell. Yes, we have BTS, and now we have the shell. And so as you can see, the EDK2 boots quite well, and we have a functional shell ready. Yep. There won't be any update later in this cinema. So now we will present an attempt to boot Linux for the RISC-V architecture using the GRUB for RISC-V. Yes, we will now map the embedded RAM disk, which we have included in the EDK build. So it is present as a simple file with GUID in the firmware image. And this is mounted as a virtual CD. And we have just switched to this virtual CD, which is FS0. We go to the FE directory, boot, and yes, we have the GRUB. We execute the kernel, but we found out that the kernel panics because of some load access fault. We haven't managed to debug what is wrong here. Maybe some things are still missing, or we didn't take the right kernel repository and branch. Okay, so I will hand over to Piotr to summarize the presentation, and thank you for attending.
Thanks, Michał. So yeah, so I'm very happy we were able to achieve that boot process. Of course, like Linux not booting yet, but the definitely like key point from that is it's not so easy. We spent a lot of effort like gluing that all together. I believe like during the discussion, Norbert will join and we can discuss like what kind of problems we faced and how much we had to do. From analysis of the authorship of the patches, there are some conclusions here, and it's very interesting. For example, that Amazon seems to be active sponsor of RISC-V development, and especially that as a main kind of member of the RISC-V Foundation is Alibaba Cloud. It's like kind of interesting observation. Of course, like Amazon did some interesting RISC-V stuff in February 2019 when they provided the FreeRTOS support for RISC-V. Yeah, so maybe they now building something which will compete with recent Alibaba processor announcement and claims about like dominating the world with that processor. It is also worth to mention that EFI stub in Linux kernel for RISC-V was provided by Western Digital. HP Enterprise provided the EDK2 support. This is very interesting news, especially in light of HP Enterprise being involved in creating evolving in open source contribution, like Sure Start documentation in core boot and various other publicly known informations that you can find. Or you can realize based on the commits and based on the analysis of what's going on. And I believe like this would be very interesting journalists' work if they will really look at this. From our own research, it looks like some companies like RISC-V as a trusted static code root of trust for measurement, so kind of alternative to Intel bootguard implementation or hardware validated boot from AMD. So they kind of add the processor to provide this this safe, known, secure, trusted processor, which will help them establish this static code root of trust for measurement. And there are also some companies looking at offload or accelerating security operations using RISC-V. So as I said, this kind of offload of the computing to another processor. Of course, like even if it may take some time to provide competing performance per dollar using RISC-V, it is worth to consider this as a companion chip, or some boards already give good performance, like Unleash, which is like a little bit expensive. There is microchip approach, which will be half the price, still a lot for something that has, like in ecosystem, we see that there is problem with booting Linux. But anyway, I believe like many of the vendors already get through that. Maybe there are some patches pending that we are not aware of. If you know something about that, please let us know. So we can move that forward. And we also watching this effort closely from Libre and Freedom perspective, because RISC-V can be good candidate. There are some small controversies around SBI, which is like you saw. So there was Open SBI, a firmware, part of the firmware booted in the QEMU. This is part of the firmware which provides special features, kind of similar to SMM, but similar but not the same. And the question is if the vendors which will build the RISC-V general purpose computing machines will kind of protect us against problems related to SBI. And of course, if you need something powerful, you can also always use OpenPower. We're doing OpenPower work and OpenPower core boot port to replace host boot. But anyway, it's good to see support for RISC-V in GRUB, and hope it will gain more and more features, and maybe at some point even trench boot support if RISC-V will get the RTM capabilities. And that would be it for this presentation and for this year GRUB Mini Summit. But I believe we have some small discussions still to get through.
Thank you, Piotr. And before we start maybe some discussion, I would like to mention 2 points of clarification. These patches for FE stub Linux booting were for GRUB, not not in Linux. So were for Linux, but not in Linux.
Okay, sorry.
Okay, and you mentioned the Sure Start documentation core boot. It was provided by some developer outside of HPE, so that it wasn't by HPE.
Okay.
I wonder if they are that really open.
Okay, sorry, like my mistake.
No problem,
So,
no problem.
But anyway, like we see that HP Enterprise will be available on open source firmware conference, and they are definitely engaged. So showing that they're doing something with RISC-V. Maybe I connected dots incorrectly, but anyway, like let's not take this call deeper. Sure. Okay. I believe like question is what value we adding in comparison to what's already inside the U-boot. I believe U-boot do not use UEFI compatible interface. Okay, so maybe I don't know, Michał, like how much it is possible, but maybe like enabling secure boot, you know, like UEFI secure boot on RISC-V. That sounds cool.
I think they probably have it, or for sure are planning support for UEFI secure. But I saw some mentions on the documentation that they are designing UEFI to have a first-class enterprise solution with secure boot for the RISC-V.
The question is how the static code root of trust for measurement would be handled, because this is like, you know, secure boot without something rooted into the hardware or in some static code root of trust for measurements doesn't make much sense. But anyway, that's cool stuff. I wonder, just my observation is, can we? So what's the policy of GRUB for testing? Because apparently we had this issue with, so someone said that they tested that on Odroid and some other target, but they didn't explain how they tested that. There is no way of external entity to say, to test that, to repeat their results. And to be honest, it was hard to find the documents about that.
In general, at this point, currently we test GRUB with all compilers, all platforms and architectures currently bulk tested. So there is no commit which was not bulk tested. Unfortunately, we do not test runtime images of the GRUB at this point, but there is functionality to do that, and we are going to use it. It requires some fixes as far as I can tell, but I think that Vladimir may add something with how it works and how to use it. The problem is that there are two issues. The one is that some tests that doesn't work well. Another issue is that all tests, if you want to run all tests, runtime tests, they take a lot of time. So this is the problem. But in general, our goal is to have build test and runtime tests. All the commits which will be taken into the GRUB. This is the goal. At this point, we are currently only build testing all the targets which are in the GRUB. So you shouldn't be able to find anything which doesn't build in the GRUB. Vladimir, could you add something?
Building is one thing, but booting is other thing.
Yes, I fully agree, but this is the first step, because at some point we had some difficulties with this, because we took some commits which broke some less used platforms, and that we realized that after a few weeks, for example, that it was broken. So the first move was to introduce build tests for all platforms to not break by mistake compiling of the GRUB. This is important. But I fully agree that the next step is to introduce runtime tests, and we are going to do that.
There is also some work for Jenkins, but it was basically shelved because of the boot hole and related work.
Yes, exactly.
And this would be most likely part of Jenkins, because runtime tests, one of the problems why it runs so slow is because if you want to run them on all the platforms, you have to emulate the platforms like PowerPC, which you can emulate it with QEMU, but which becomes pretty slow. And then if you run the full test suite, it ends up trying all the resolutions, all the font rendering options, and then the entire test takes like half an hour just for PowerPC platform.
Okay, I find out there are two ways to test the boot for GRUB-FE. One way is that we are presenting here in our presentation. The second boot flow is OpenSBI with U-boot, and then U-boot is calling the GRUB, and GRUB is loading the kernel. Is there any difference, or is there a preferred way to test the GRUB-FE, or
in general, if you are going to use the U-boot, my understanding is at this point that in general the UEFI interface will be the main interface which will be supported only by U-boot, and at least GRUB is going to drop all things which is not non-EFI for U-boot platforms. This is the plan, and my understanding what is going on in the U-boot environment. So I think that yes, you should focus on UEFI testing. This is quite important.
Okay, I understand. Thank you.
You're welcome.
From our perspective, I believe we would like to work also on core boot part and making core boot work with GRUB. But you know, like everything what's good coming to an end, and like we probably have last like 5-10 minutes to sum up the GRUB Mini Summit 2020. So maybe I will start with some summary. First of all, thanks everyone, starting from Vladimir, that was available on all sessions, I believe, or almost all sessions. And Daniel, of course, to you, that you brought maintainers and other contributors to GRUB. Also 3M Dev team for providing a lot of effort related to preparing all this software stack presentations and so on. But now I'm thinking about moving forward, and next year, of course, like definitely we want to do that. But the question is if we will do just GRUB Mini Summit. Maybe we should change the form into bootloader Mini Summit and try to kind of compare various bootloaders and have like also maybe like see the feature sets and threat models and security stuff from various perspectives, and also from the perspective of how we interact, and that would be to some extent interesting. But then the question is, of course, what's bootloader? And now we have flame war because, like, you know, there is no definition of that. There are some people saying that core boot is bootloader, which I'm not sure if core boot people agree, and so on and so on. But maybe this is a rough idea and it needs some polishing and some internal discussion. But anyway, I would like to extend the scope of this meeting. Right now, we of course like gathering some audience, and there are people that watching these videos after. But still, I'm thinking about moving this forward and you know, catching more trends related to booting. Especially, I'm interested about two interfaces. As I said, like the initial idea of this, at least from my perspective, was to discuss the interface between the firmware and the bootloader, and the bootloader and the operating systems. So those interfaces are the most interesting to us. And what we can do on those interfaces, how we can improve those interfaces, is something that would be the goal of this kind of meetings in further years. So once more time, thank you very much for helping. And I don't know, Daniel, if you want to say something, or Vladimir.
Yes, sure. I would like to say, I would like to thank you, Peter, Michał, Norbert, Małgosia, and Kamila for organizing this event. I think that it would not happen with 3M Dev folks, so this is important. And I think that we brought a lot of the interesting topics during this mini summit, and I hope that at least one or two will be able to pursue during next year, and then we'll be able to present something which is during next, whatever we will call GRUB Mini Summit or Bootloader Mini Summit, doesn't matter, but we'll be able to present something which is fully ready and upstream in the GRUB. So this would be my goal for next year. And it was very interesting, and I would like to see you next year.
Yeah, it would be great also to get like more kind of other perspectives, like what kind of other problems are in bootloaders, because right now we are very hermetic about, like, we are embedded firmware developers and we're showing only this perspective, and kind of it is hard for us to look from different side, like from let's say, I don't know, like distro maintainer side, or I don't know, maybe independent BIOS vendor side, like proprietary BIOS vendor side, and so on and so on. Maybe like Linux vendor, Linux notebooks vendor or laptops vendors side. This is also interesting perspective. So gaining other perspectives would be great. And of course, that means building a better community, extending the community, and sure, it should result with some contribution, with some improvements in the release notes of next GRUB release, not this one, but the next one. Yeah, not this would be probably 208. We will talk. Yeah, but anyway, Vladimir.
Yeah, I also would like to thank you for organizing this. I enjoyed it, and I think it will be useful for solving the problems. And I think it might make sense, like rather than constraining into having it once a year, we can have ad hoc presentations or ad hoc discussions more often. Like rather than having it, when I think it was 4 times 2 hours, have just 1 hour at some point to discuss some specific problem, which because usually mailing list is a fine way of discussion, but sometimes when a discussion takes too long, it might make sense to just meet all together virtually and discuss it.
Sure. I agree.
Yeah. So I believe I also agree. This is a good thing to have like some technical call or something like that. I was also asked about that, about animating something like that for CubesOS. But to be honest, like from our perspective, like long-term planning is like we have to have stable schedule. And of course, if there is need, we will be glad to do that. If there will be some interesting features that needs this kind of discussion, that would be great, and we can do ad hoc stuff. But then in case of like kind of planned presentation or this kind of stuff, like it's better to have a date agreed between us, so everyone can prepare something which, you know, there is cool demo, there is some console.
Ad hoc does not mean the next day. I mean more like not grouped.
Okay. Sure. Thank you very much, Vladimir. Thank you, Daniel. Thank you, 3M Dev team. And let's talk at some point next year.
Okay, thanks a lot. Bye, guys.
Thank you. Bye-bye.
Thank you very much. Bye-bye.